Welcome, and thank you for joining us at Developer Summit 2021. This session about ArcGIS Enterprise on Kubernetes will focus on giving you a technical introduction, including some details and demonstrations about the intended architecture and administrative workflows. Because we have not finalized all of the software, some elements of the UI that you see in the demos may vary from what is eventually launched. At Developer Summit 2021, you may also be interested in the companion session about ArcGIS Enterprise on Kubernetes technical concepts. Let's begin.
Hello, my name is Tls Certificate, and I'm the lead developer and architect for ArcGIS Enterprise. Today I'm going to talk about key concepts and architecture of Enterprise on Kubernetes. It is our vision to deliver a new cloud-native option for our enterprise customers, one that is geared for scale, resiliency, and maintainability. This complements our current offerings on Windows and Linux. And it is this vision that is driving us to design, build, and deliver a modern microservices architecture on Kubernetes. There are three main concepts that drive the design and architecture. Some of you may already be familiar with them, but we will review each one in this short introduction. Enterprise on Kubernetes leverages containers for software delivery, Kubernetes as the container orchestration layer, and a microservices architecture for scalability and resiliency. Containers are a way to package code and configuration file as an image. They're a great way to capture the environment in which our code executes. They're immutable in the sense that you cannot change them without creating a new image. It is generally believed that running containers on a node is more efficient than running virtual machines, as they share a common operating system with the host OS. Containers are delivered via a container registry. Even software patches and new releases are delivered via the same registry. A CI/CD pipeline can build container images and then push them to the registry after undergoing testing and certification. These registries can also be mirrored or replicated. This helps some organizations who may not be connected to the internet or who may want additional security. Docker is a popular container format, and it is our choice for our images as well. We'll be delivering these container images via Docker Hub at 10.9. In order for a node or a computer to run software in a container, it needs a container runtime like Docker. For small applications, administrators can manage containers on a few nodes using simple tools. But how would you manage a containerized application across a fleet of nodes, using tens to hundreds to even thousands of nodes? That's when you need a container orchestrator. Kubernetes was developed as a container orchestrator at Google, and it has now been open sourced. It is one of the most popular container orchestrators and has a massive community behind its development and adoption. Kubernetes is the software that manages the lifecycle of containers across many nodes. You can almost think of it as a new distributed operating system. Kubernetes is available as a service by most cloud vendors like Microsoft Azure, AWS, and Google. It is also available on premises via vendors like Red Hat's OpenShift and VMware. We'll look at the Kubernetes architecture in the next slide to better understand how it operates. This is a simplified architecture of a Kubernetes cluster. A Kubernetes cluster is made up of a set of networked nodes. The cluster is typically connected to a container registry from which it downloads images to run within the nodes in the cluster. A control plane or a Kubernetes master manages the containerized workloads across the pool of worker nodes. Most cloud vendors offer the control plane as a managed service. This means that it's highly available and something that you don't need to look after. It has three important components that run within the control plane. The API server that exposes REST API for Kubernetes, an etcd key value store that acts as Kubernetes' configuration store, and a controller or a scheduler that performs the real work of orchestrating applications and managing the cluster. The worker pool is a scalable pool of nodes of a certain kind and a certain size. Nodes have a runtime, such as Docker in this case, and a Kubernetes process called kubelet that manages the applications on that node. A pod is a Kubernetes term for a running container instance. Applications can be made up of many such pods across the nodes. And based on the nodes, the worker pool can be configured to scale automatically. And as a result, the provider will add nodes to the cluster if there is additional capacity that is needed for your applications. Volumes are represented as objects called persistent volumes in Kubernetes and are attached to the pods. They represent the storage should the pod need any. For example, in the case of a Postgres pod that needs to write data, it's going to write data to a volume attached to it in the form of a persistent volume. Once a desired state of an application is programmed into Kubernetes, it constantly strives to achieve it. If the pod fails for some reason, the failure is detected and another instance of the pod is started. If the whole node fails, all the pods on the node are shifted to new nodes. In this way, Kubernetes helps us achieve resiliency for our applications. ArcGIS Enterprise supports Kubernetes clusters deployed to EKS on Amazon, AKS on Azure, and OpenShift on premises at 10.9. Microservices are an architectural style of building distributed systems made up of loosely coupled components. And because of their loose coupling, they are easier to manage, think patch and upgrade, and easier to scale. These components often communicate with each other over a well-defined API or a protocol like HTTP. Typically, a microservice tends to focus on a small piece of functionality rather than the whole thing. Now, you may be wondering that ArcGIS Enterprise has always had REST APIs for its geo services and administration. So what's new with Enterprise on Kubernetes? With Enterprise on Kubernetes, we've done the hard work of breaking down the functionality that power these REST APIs into small, easy to deploy and easy to manage components. So when we combine our three concepts together, we are using containers to package and deliver software to you. The containers run on a Kubernetes orchestrator, and they power these microservices that bring ArcGIS Enterprise to life. Before we dive into Enterprise on Kubernetes, I want to talk a little bit about cloud-native architecture, what it is, and why is it important. Cloud-native architecture is a design pattern for building cloud-based and cloud-scale applications to take advantage of what the cloud has to offer. One of the key tenets of a cloud-native architecture is that components be loosely coupled, as they allow for improved scale, observability, and manageability. Containers and Kubernetes are one way of achieving the loose coupling, and that is what we are delivering with Enterprise on Kubernetes. But just like this Dilbert comic, simply saying that an application runs on Kubernetes doesn't really solve all of the world's problems. In order for an application to be cloud native, it must take advantage of what the cloud has to offer in terms of elasticity and the spectrum of managed services that are available from storage to compute engines and everything in between. Now, we will continue to make strides in our ability to take advantage of the cloud in upcoming releases. After reviewing the key concepts, let's look at the architecture of Enterprise on Kubernetes. The architecture may look a bit intimidating at first, but I'm going to walk you through it systematically. Before you begin, you need to download from my Esri the deployment scripts and license files. Remember that the bulk of the software is in the container registry, so the initial download from my Esri is just a handful of scripts. The next thing that you need to have is access to the Docker Hub Registry. Kubernetes is a prerequisite for deployment, and so you can use EKS on Amazon, AKS on Microsoft Azure, and for on-premises customers, you can use Red Hat's OpenShift as your Kubernetes cluster provider. Using the Kubernetes providers tools, you must provision a Kubernetes cluster with a worker pool of nodes. If you're using a previously created Kubernetes cluster or a shared Kubernetes cluster, you need to create a namespace in which Enterprise will deploy. Using the deployment scripts, you deploy a core set of components in a namespace within your cluster. The core components includes the admin API, the ingress, and Enterprise Manager. And this usually takes about 5 to 10 minutes. The next step is to configure your Enterprise. To configure, you can either use the scripts or the Enterprise Manager web application. During configuration, the admin API assembles your base deployment using microservices. Once the base deployment is configured, you can front it with a load balancer or an ArcGIS web adapter. We ship a Java and a .NET-based web adapter to accommodate your PKI or IWA authentication mechanisms. The job of the load balancer is to route all traffic to the ingress pods running in the cluster. We ship an Nginx-based ingress as a part of the enterprise. The ingress pods then route the web traffic to the targeted microservices pod. The admin API microservice can be thought of as the controller for the enterprise. It exposes the familiar admin REST API, but it also runs a control loop to observe other microservices. Enterprise Manager is a new web application geared for administrators of enterprise. Portal components like the Services API, the portal application, as well as the suite of web applications embedded are separated out into their own microservices. To support the base deployment features of ArcGIS Enterprise, the system needs hosted data stores like Postgres, spatiotemporal Elasticsearch, or an object store. These all run within the cluster as separate pods and can be administered via Enterprise Manager. You will notice that there are multiple pods running off these hosted data stores. And that's because all the hosted data stores run by default in a highly available configuration. The server pods run specific type of services. Let's take a few examples. The feature server pod runs all the hosted feature services. Map services can run using shared instances, in which case they will run multiple map services in a shared instances pod. But you can switch its mode to run a dedicated instances, in which case a single map service will reside in a single microservices pod. System and utility services like caching, geoprocessing services, or printing tools all run in their own pods. While I've shown only a single pod of a kind for simplicity, all of these pods can be scaled individually, and you can even adjust their counts or the CPU and memory they can use. An enterprise architecture cannot be complete without talking about your data. And we expect your data to be in data stores like folders, cloud stores, or enterprise geodatabases. You continue to register them with the enterprise and use them like you've used them before for publishing services and creating content. In addition, you can federate a GIS server site running on Windows or Linux to this base deployment. This will allow us to complement and complete GIS capabilities that are not yet in the base deployment on Kubernetes. Once you have a deployment that is working for you, subsequent patches and releases are upgradable via the admin API or enterprise manager at the push of a button, just like any modern software. Availability and scale are two broad topics that will be covered in much more detail in subsequent presentations. But I'll highlight a few key points. We understand that availability and scale are a spectrum and one size does not fit all. In the architecture and design, we paid careful consideration to not have a single point of failure in the default highly available configuration. The number of pods or replicas can be adjusted to meet a certain throughput or scale requirements. One can even configure fine-grained resources like CPU and memory allocations on a per microservices basis to tune the system for very specific needs. In summary, Enterprise on Kubernetes is a new option that complements the Enterprise on Windows and Linux. We've done the work to design and implement a truly microservices architecture. It comes as a base deployment, and while it is made up of individual components and containers, you cannot deploy these containers in an a la carte fashion. It comes together as a part of your base deployment. We've preserved the GeoServices REST API that allow applications to consume the GIS services much like before. You also continue to register your data stores with Enterprise and use it for publishing services and creating content. Lastly, a federation with a Windows or a Linux-based GIS server is supported to complement the capabilities on the Kubernetes-based base deployment.
Hello, I'm Subrat Bora, and in this section, I'm going to talk about preparing for deployment of ArcGIS Enterprise on Kubernetes. For this demo, I'm going to show you how to deploy an AKS cluster. And obviously, you'll need an Azure subscription to deploy an AKS cluster. The basic steps to create a cluster are the same on both Azure and AWS, with some cloud-specific differences on each platform. The workstation will require network connectivity to Azure Cloud, Azure command line interface to interact with the cloud services, Coupe control command line tool to control the Kubernetes cluster, and OpenSSL toolkit. Now let's go to the demo. Let's tackle the client workstation part first. The first step is to install the Azure CLI on the client workstation. I'm using MacBook with macOS Catalina as my client workstation. Microsoft has documented very well how to install Azure CLI on a specific platform. So you can visit Microsoft documentation to find out how to install Azure CLI on your workstation. I'm going to install on macOS, so I'm going to use Homebrew. It's brew install Azure CLI, then hit enter. It's going to take a few minutes to install the CLI. The next step is to log in to the CLI using Azure command. Login is the command. It will show you in the terminal whether the login is successful. Once you are logged in, you can create the cluster using Azure CLI command option. For this demo, we are going to use Azure Portal to create the cluster, not the CLI option. Now let's go ahead and install Coupe control tools. You can install Coupe control using Homebrew on macOS or a package manager specific to your Linux distribution. I'm going to use Homebrew. So the command is brew install Coupe control, hit enter, and it's going to run and install Coupe control. Now let's go ahead and open Azure Portal to create the AKS cluster.
Now go to create resource, search for Kubernetes service, and hit create. Fill out the basics appropriately. You can create a new resource group or use an existing one. Here I'm going to create a new one and let's call it tech demo. Enter the name for the cluster. Select Kubernetes version. I'm going to select the latest stable version. Please check our system requirements for the supported versions. Here you need to define the number of worker nodes that you need. And we require minimum 3 for the default deployment and choose the size according to your need. Please check system requirements for minimum node size At this point, we require 4 core and 16 GB per node. Remember, on cloud-managed Kubernetes services, the control plane and master nodes are managed by the cloud provider. One difference here between AKS and Amazon EKS is Azure creates the worker nodes with the cluster when you create the cluster. But in EKS, the cluster is created and then you'll have to create the worker nodes once the cluster creation is completed. Click Next to go to Node Pool Properties page. I'll increase the max pod per node to 250 from default 110. Currently, we deploy 44 pods with ArcGIS Enterprise. If you plan to deploy multiple ArcGIS Enterprise on the same cluster, you may need to increase the max pod per node to accommodate more than one ArcGIS Enterprise deployment on the same cluster. Click Update. Click Next to go to Authentication. Role-based access control must be enabled. All of the rest, I'm going to accept defaults. Next, you customize your network here if you wish to. Next, integrations like Container Registry attachment and Log Analytics workspace. I'm not going to attach any Azure Container Registry here. Next, tags, and then finally review and create. This will take anywhere between 15 to 30 minutes depending on what you have defined in the previous steps. Once the cluster is ready, you'll need to download the kubeconfig file on your workstation to connect using kubectl command. I'm going to show you how to download the kubeconfig file from your terminal. To get the kubeconfig file, you'll run this command, AZAKS, then resource group name, and then the cluster name. Once you hit enter, it'll download the kubeconfig file locally on your workstation. And now let's test if you can connect to the cluster successfully. Now, if you type the command kubectl get nodes, and if you can see the nodes, that means you can connect successfully. I want to mention a couple of things before concluding the demo. ArcGIS Enterprise and Kubernetes requires persistent volumes, which can be created dynamically during the deployment. You'll need to define a storage class during deployment. You can use a storage class which comes default with the Azure cluster. We recommend to use a block storage, that is Azure Disk, as persistent volume.
Hello, and welcome to the deployment and setup presentation for ArcGIS Enterprise on Kubernetes. My name is Marcus Walker, and today I will be presenting this topic to you. In this presentation, I will discuss the deployment experience in detail. This includes insight to the design of the deployment setup experience, as well as a few demos. If you ever find yourself wondering what is next, just remember these 3 steps: deploy, configure, and use. You will be provided with a tar.gz file that contains the following scripts: deploy.sh, undeploy.sh, and configure.sh. These 3 scripts will enable you to be able to successfully deploy, configure, and use ArcGIS Enterprise on Kubernetes. You will need to ensure that you have a client machine with a bash shell and a Kubernetes cluster that meets the system requirements defined in the documentation. The deploy.sh script was purposely designed to provide the same experience across these providers. Regardless of your supported Kubernetes provider, one deployment script, one deployment experience. Here we are in my Kubernetes cluster. I ensured that I have met the system requirements, and now I am ready to perform step 1 of our flow, which is to deploy. After we untar our .tar.gz file, we are left with the deploy.sh script, undeploy.sh script, and additionally, we have the configure.sh script, which is found here in the Tools folder underneath the Configure folder. To start this demo off, we will begin with interactively running the deploy.sh script. To do this, all we have to do is simply run the script without passing any arguments to it, such as this. It is important to note that the deploy.sh script prompts for several pieces of user input that is required in order to successfully finish step 1 of deploy. In the first section of deployment platform, the ingress will ensure that incoming traffic is routed to services within your Kubernetes cluster. Should you be using Amazon EKS or Azure AKS, please be aware that the ingress controller can be exposed externally using a load balancer service. Should you choose to do this, please be sure that your cloud load balancer is provisioned before running this deploy.sh script. This script will take information that you pre-configured within your cloud infrastructure and then apply it to your Kubernetes cluster. The brackets throughout this deployment script signify that that is the default option should you press enter, such as this. Within your namespace, please be sure that this is a dedicated namespace for ArcGIS Enterprise on Kubernetes. By design, the script will not create a namespace for you within your Kubernetes cluster. This was done to ensure that the deployment script is not overly intrusive on your client machine. The container registry is where the ArcGIS Enterprise on Kubernetes images reside before they are pulled to your Kubernetes nodes during deployment. By default, docker.io is the registry host that the script recognizes. The FQDN that you specify is how you will be accessing ArcGIS Enterprise on Kubernetes. This can be through a load balancer, reverse proxy, edge router, web adapter, or any other front-end point that can be configured to route incoming traffic to the ingress controller. Immediately following your FQDN in your URL to access ArcGIS Enterprise on Kubernetes will be a context path. By default, the value we see here will be ArcGIS. However, you can customize this to be whatever you would like. This script takes full advantage of the awesome Kubernetes feature of automatically port allocating any available port. If you press enter right now, the script will allow Kubernetes to select an available port. If you would like to select a port in that range yourself, you are perfectly free to do so. Just make sure that the port is open. The second to last section that we have to fill out is a TLS certificate portion. A TLS certificate is required for the ingress controller to successfully enable encrypted communication. As shown here, there are 4 options from which you can choose. This was done to ensure flexibility for organizations on how they choose to have the ingress controller enable encrypted communication. Now we are asked about a properties file. This section is cool because all of that user input that we just inputted, well, the deployment script tracked all of that information, and it is now going to put that into a generated properties file for us. What that means is that should we wish to have a redeployment or undeployment of ArcGIS Enterprise on Kubernetes, we can directly reference this properties file, and we will not be asked to enter in all that information all over again. Here we see all of the information that we just inputted, and that is captured in our demo.properties file. If that all looks good to us, we will press enter to finish step 1 of deploy. Now we are waiting for our 4 startup pods to successfully come up and be in a status of running. Alright, we have successfully finished step 1 of deploy, and we have some information that is outputted to us. Our first URL that we see here shows us the URL needed to proceed to step 2 of configure via the setup wizard. The second URL that we see here, that is our help URL. That will be helpful for us as it gives us our own local documentation to refer to should we wish to learn more about ArcGIS Enterprise on Kubernetes in general. This last URL, it looks a bit similar to the first URL, right? Except that there is the addition of our node port there. Should you choose to use the web adapter to allow ingress to communicate through, you will want to ensure that you finish step 2 of configure using this URL. This will be needed as you need to first create an enterprise organization before you configure the web adapter. In order to create an enterprise organization, we will need to ensure that we access the ArcGIS Enterprise Manager setup wizard. If you are familiar with the experience of creating a site on ArcGIS Enterprise on Windows or Linux, then this process will be familiar to you. Once you successfully finish step 2 of configure, this is what your deployment will look like underneath the hood. We see that now all the empty spaces are now filled with pods and their bounded PVs. Let's now jump into our second demonstration of creating an enterprise organization via the Enterprise Manager Setup Wizard. Whether you put in your node port URL or your load balancer URL into your browser given to you by the deploy.sh script, you will be redirected to this ArcGIS Enterprise on Kubernetes Setup Wizard page. This process will download Esri Docker images, deploy containers to your Kubernetes cluster, and finally, it will go ahead and create an enterprise organization. Let's click Continue. In step 1, we will need to ensure that we authorize ArcGIS Enterprise on Kubernetes with the appropriate license files for our enterprise portal and for our GIS server. Along with the .tar.g download file where you got the deployment scripts, you should have these license files available to you as well. And we will go ahead and press Next. Now is where we will enter in our account information for the primary administrator. Notice how there was built-in logic to ensure that we are meeting the requirements for each field. This section will prompt you for storage information that will be used to hold site information, your user data, any backups, and much more. Please be aware that whether you choose to use dynamic or static PV storage, this will need to be already applied to your Kubernetes cluster. I'm going to go ahead and choose Next. Now we see we are at the configuration summary to wrap up step 2 in our flow of configure. If that all looks good to me, I will go ahead and press Finish. Now we see that the enterprise organization is being created, and as pods begin to be successfully pulled down and put onto my Kubernetes cluster, I will see updated status reports right here of my enterprise organization creation. And as we see, we have the first pod that's pulled down, our relational database provider, as well as the config store. You will see this process continue until you have all of the pods successfully finished. We see that we're given back 2 URLs, one to access our enterprise portal and one to access our enterprise manager. This signifies that we are now done with step 2 of configure, and now we are ready for step 3 of our flow, which is to use the software. Remember, when all else fails, remember the flow. Deploy, configure, and use. One deployment script, one deployment experience. Regardless of your supported Kubernetes provider, the underlying result is designed to be the same as we saw in the demos. We walked through how to successfully configure an enterprise organization using the ArcGIS Enterprise Setup Wizard and Enterprise Manager. Silent deployment and configuration is also supported.
Hi, I am Eva. I'm the lead product engineer for the ArcGIS Enterprise on Kubernetes. I'm excited to introduce you to a new system management tool that will help you to manage ArcGIS Enterprise on Kubernetes. You will need a system management tool to manage ArcGIS Enterprise. How do you perform day-to-day system administrative duties and make sure ArcGIS system is healthy and running properly? How do you begin to perform the system administrative task to make sure the ArcGIS system is healthy? For ArcGIS Enterprise on Kubernetes, we introduced this new system management tool to help you perform day-to-day duties of maintaining, troubleshooting, and administering the ArcGIS system. After your initial deployment, the Enterprise Manager pod is deployed to your Kubernetes cluster. You can bring up the setup wizard to configure your organization after the initial deployment. When the organization is successfully created, you can immediately log in to the manager application and begin to use it for your administrative tasks. We want to build an ArcGIS Enterprise management tools that tailor toward IT system administrator who are tasked to administer, repair, monitor, and maintain the stability of the GIS system deployed in Kubernetes clusters. ArcGIS Enterprise Manager attempts to unify the administrative experience to manage the enterprise infrastructure and system as a whole via a modern application interface. The intuitive user experience around common administrative and management workflows will allow you to manage the system with fewer clicks. The Manager application also enhances the system's observabilities and provides insights to the health of the system. This will empower administrators to identify and rectify problems and issues effectively in a timely manner. You can build, discover, and apply updates and upgrades seamlessly to the system from a common interface. Finally, ArcGIS Enterprise Manager is localized to support our international users. To begin to use ArcGIS Enterprise Manager, you will need to first sign in with your administrative account. The first thing you see in an overview page, which will provide you an insight to the health of the system. From here, you can check the critical logs, the status of all the system managed data store, and the system and utility services. From the security menu, you can see an overview of your security configurations as well as manage your TLS and trusted certificates for your organizations. You can also configure the identity store and proxies. You can use ArcGIS Enterprise Manager to configure your system, utilities, and GIS services. You can search for services, tune resources limits, or scale up and down on the number of ports for individual service based on usage. You will also be able to convert a share map service or host a feature service to a dedicated map service or reference feature service to meet the demand of your users. To adhere to the log retention policy for your business, you can now specify the log levels as well as the time period of the log message you want to delete, keeping the ones that are useful for security review if needed. You can register your backup stores and manage the backups from the backup and restore menu. Should a disaster strike, you can also restore your system from one of your backups in this menu as well. From the update menus, you would be able to find information such as what version of ArcGIS Enterprise you are using and when the last update was applied. You would be able to discover what updates would be available for the version of software you are on, or if a new release has become available. Yes, you can roll back an update if you need to. There are other things you would need to configure for ArcGIS Enterprise, such as server licenses. It will display the server roles and extensions your enterprise is licensed for. You can also update your license if you need to. Should you choose to configure a web adapter to support web tier authentication, such as integrated window authentications or PKI, you can acquire web adapter token to be used to register your web adapter with your enterprise deployment. And how about you would like to host your own registry and would like to configure ArcGIS Enterprise with a new registry? You can find these configurations under the Configurations Options menu. ArcGIS Enterprise Manager will now be the tool for you to easily and efficiently manage your ArcGIS Enterprise deployment in your organizational Kubernetes clusters.
Hello everyone, I'm Nithi Arora and I have my co-presenter Vaibhav Singh with me. We are product engineers in the enterprise team and we are working in the team that builds upgrade functionality. In this presentation, we will take you through the journey of upgrading and patching ArcGIS Enterprise on Kubernetes beyond 10.9. In the software page in Enterprise Manager, you can see the current version of your system, discover new releases and patches or updates once they are available to you. You can also use this interface to apply patches and upgrade your system to the next release. Enterprise leverages upon following upgrade strategies: rolling update and blue-green update. We will talk about them in a minute. Now, all the pods in the enterprise can be classified as stateless or stateful. Stateless pods like Home App, JavaScript API, these are the ones which do not persist any state, whereas stateful pods are the ones which are tightly coupled with some state like admin or portal, or they store state like data stores. Stateless pods use rolling updates and stateful pods use blue-green update to upgrade from one version to another. Now let's take a deep dive into rolling updates. Here we have two versions of pods, A, old version, and B, the new version. Initially, two pods of old version use some persistent model. At time T1, a new pod is created. Due to stateless nature, it can use the same data model. At time T2, one of the old pod is teared down, and at time T3, a new pod is created. So this process of gradually replacing old pods with the new ones is continued till the time system is completely updated with the new pods. Here we have two pods of old version A that are connected to some persistent state. Now the new set of pods are not backward compatible or cannot use the same persistent model. So new system or the green system is created. At initial time T1, data is migrated from the old or the blue system to the new system and thereafter upgraded to the newer version.
We are going to perform a patch update operation. As soon as we click the apply button, the system will ask for the reconfirmation. Now, these updates are cumulative in nature. If we apply any update, all the updates of earlier version will be automatically applied. For example, our system is at version 10.9.0.907 and we want it to be patched to version 970. The system is automatically applying all the earlier version, which in this scenario is 950. Clicking on the apply button will start the update process. As soon as the update process starts, we can see the progress of the process through messages. Also, the system will go into the read-only mode. The History tab shows all software update opportunities your organization has taken till date. It allows you to view the logs for troubleshooting if there are any problems with your update or upgrade. Rollback functionality works in a similar way. On click of Remove button, the system will again ask for the reconfirmation. And as the updates executes in a cumulative manner, in a similar way, if we are intended to perform rollback for 950, release update doesn't support the concept of rollback. Therefore, it is highly recommended to take the backup before starting the process. Here, we have already one release upgrade listed. On click of this upgrade button, the system will ask for the reconfirmation. On clicking the continue, the process will start. A user can monitor the progress of the process by looking into these status messages. As the process moves forward, with the passage of time, these messages will also provide information that how many containers already got upgraded as a part of this process. Now, in a similar way like updates, here also, as the process starts, the system will go into the read-only mode. The read-only mode means a user can access the existing item but cannot edit it, and also he won't be able to add any new item.
Now let me walk you through the API that powers the upgrade process. The API can be found under Admin System Upgrades. So check available updates. This function returns the cumulative list of updates and the next release that has been made available for you. Upgrades either through an update or a release. Check installed updates returns cumulative list of updates and the releases that have been installed. Check rollback option returns a list of possible rollback options depending upon the update that has been applied. Rollback uninstalls an update. Current version returns the current version of the system. And lastly, history returns the transaction history for all the upgrades and rollback operations that have been performed on the system. Finally, key takeaways. Please keep these points in mind. We are using blue, green, and rolling update strategy to update all the pods. You can discover and apply updates and upgrades through Enterprise Manager. Now, during update and upgrade process, system will not be completely inaccessible, but will be in read-only mode. And patches can be rolled back, but release upgrades cannot be rolled back. Please ensure to take backup before starting the release upgrade process.
Thank you for joining us at Developer Summit 2021 and participating in this session about ArcGIS Enterprise on Kubernetes. We hope you found it helpful, and we hope to hear from you soon. Please enjoy the rest of the conference.
Hello, and thanks to everybody who's been watching. I'm Trevor Seaton on the ArcGIS Enterprise Product Management team and helping to moderate questions. Our team has introduced our work here to build an additional deployment option for enterprise based on Kubernetes with a walkthrough of some of the exciting changes and what it might mean for you. So we're looking forward to responding to as many questions as possible, and there have been a lot of them. There will be a second session on Kubernetes immediately after this one, and there will be different and more information about the project there. So please be sure to attend that session again immediately following this one. Both sessions will be recorded and available to you. I'm going to take the very first question here, which has been asked a few times, and that is how the Kubernetes deployment is going to be licensed. Now, we know this is a new architecture and a new way to deploy enterprise. Could have been many ways to set up pricing and licensing, but we wanted to keep things simple. So we took the approach of not creating specific licensing or pricing requirements around the Kubernetes deployment option. However, there are some eligibility requirements, and one of them is that you have an active enterprise agreement. There are some other things to consider, and we're going to ask that you talk with your account manager, Esri account manager, for more details on that. We're going to jump to another question here, which is, does ArcGIS on Kubernetes require a full portal deployment? So can it work with just ArcGIS Server and Sde? And I'm going to ask Mogan to respond to that one.
Hi, Trevor. Thank you. My name is Moganraj Mohandas. I work as a senior product engineer on the team. So when you deploy ArcGIS Enterprise on Kubernetes, you are deploying what you traditionally know as the base deployment, which contains a portal for ArcGIS, ArcGIS Server, and the ArcGIS data store functionality, that similar functionality to what you will have with those components. But you can additionally federate ArcGIS Server, standalone ArcGIS servers on Windows and Linux with your ArcGIS Enterprise on Kubernetes deployment. So that is possible. We have specific roles that you can federate for 10.9, and we're looking to expand the server roles that you can federate in future releases. Thank you.
Thank you, Mogan. The next question is about high availability and how it can be ensured in enterprise. So the current model suggests having two portals joined together. And does Kubernetes on its own ensure high availability of enterprise? And I want to say first that in that second session we have coming up, we're going to cover this in more detail, but I'll ask Eva to give maybe an initial response on this. Eva, are you there?
Sorry, I'm trying to unmute. Hey, this is Eva. ArcGIS Enterprise on Kubernetes is a new offering that support ArcGIS Enterprise on Kubernetes. So ArcGIS Enterprise is highly available out of the box. The way we can support that is to leverage the orchestration capability for Kubernetes, as well as the auto scheduling for the containers that enable us to set rules to enable high availability out of the box.
Thank you, Eva. I appreciate that. Next question is, from our experience so far, would we expect Kubernetes to be similar, cheaper, or more expensive to operate in a comparable virtual machine cloud deployment? I'll ask Subrat to respond to that one, please.
Hi, this is Subrat. So this is really a little bit tricky question, but the straight answer is if you have a large deployment with HA currently on VMware or Cloud VM or on-premise cloud or public cloud, if you have a large deployment of 3-4 VMs, you are definitely going to maximize your ROI, return on investment, using Kubernetes. But if you have a small deployment, just a base deployment on one VM, using Kubernetes is not going to give you maximization of your ROI. So if you have a large deployment, yes, definitely you're going to benefit, get more benefit. And not just VM pricing wise, on operation pricing wise also, because traditional architecture, there are challenges when you go through high availability, disaster recovery, scalability, and sudden burst, like burst of requests, handling all those situations. But with Kubernetes, we are really addressing those concerns. So operation wise, and also from hardware perspective, you're going to maximize your return on investment if you have larger deployments. That's the answer.
Thank you, Subrat. I appreciate that. Next question is a question about SOI or SOEs extensions. Does it support customization like SOIs or SOEs? Can it be done through extending the containers? Shreyas, would you respond to that one, please?
Sure. Thanks, Trevor. My name is Shreyas. I'm the lead developer for ArcGIS Enterprise. That's a good question. So at the initial release, Enterprise on Kubernetes has a base deployment that runs on Kubernetes, but you can also federate a GIS server on Windows and Linux, and that can be attached to this base deployment. So at the initial release, server object interceptors and extensions can be run and deployed on the Windows and Linux-based GIS server that's federated with your system, but not within the Kubernetes cluster itself. This is something that's come up, and we will be actively pursuing it in the subsequent releases.
Thank you, Shreyas. Thank you, appreciate that. We've had a few questions about the supported environment. So just to be very clear, this was kind of shared in the recording or the presentation, but we will support at the time we launch Elastic Kubernetes service on AWS, Azure Kubernetes service, and for an on-premises, we will support Red Hat OpenShift. There are other engines we're looking at, including the GCP, Google's Kubernetes engine, and others. Those will be on our roadmap, not available at initial launch, but please stay tuned for updates on that. And we do expect to get to those fairly quickly. For the next question, let's talk about deployment a little bit. Will this deployment work in local development environments like Minikube and et cetera? Eva.
So ArcGIS Enterprise on Kubernetes is only supported on OpenShift, AKS, and InKS. But if you would be setting up although it's not tested or it's not supported, but if you wanted to set up your own Kubernetes cluster that conform to the Kubernetes standards, you would be able to try to deploy it for testing purposes.
Thank you, Eva. Let's get to a little bit of a different question here, and this will also be for Shreyas. The question is, ArcGIS Enterprise components are fairly tightly coupled across the federation. ArcGIS Pro also has dependencies and on Active Directory and roaming profiles and local storage. So are you looking at ways to make components of those products more ephemeral to support spin up or spin down of these products to minimize costs?
Thank you for the question. So Enterprise on Kubernetes is a set of components that run on the Kubernetes cluster. Now, the cluster can be in your own infrastructure on premises, or it could be on Azure or AWS. To run it, it doesn't need Active Directory, but you can connect Enterprise on Kubernetes to an Active Directory as your identity provider, as a provider of user accounts that you can use in your enterprise systems. For storage, it uses a block store that's available in your cloud provider, on your on-premises provider. And the enterprise can be managed using Manager or using the API. So you should be able to scale your components to the level of SLA and performance that you desire, and then shut them down or tear them down accordingly. But I think what you can't do is the base deployment as a unit that's available and deployed for you. You can't piecemeal take components out and run them in isolation. So it's enterprise on Kubernetes as a whole that's available to you. And you can scale the microservices, various microservices within it, but you can't piecemeal take components and shut them down. Back to you, Trevor.
Thank you, Shreyas. There's a great question about the deployment experience. So I want to make sure we get a chance to talk about this. And the question is, how long does it take to complete a typical base deployment? Marcus, maybe you could respond to that one.
Sure. Thank you, Trevor. My name is Marcus Walker. So that is a great question, indeed. So with regards to the amount of time you can expect ArcGIS Enterprise and Kubernetes to finish deploying, it really does depending upon your environment, right? It is a bit contingent with regards to the resources you have provided to that particular environment that's deploying and configuring Enterprise and Kubernetes. In general, we do see just through our testing that generally underneath an hour is when most environments can expect to be finished. But I do want to stress again that it does vary depending upon your unique environment and its resources allocated.
Thank you, Marcus. Appreciate that. Here's a question also about basically, I guess, a question about can we deploy Portal and ArcGIS Server in one Azure Virtual Network group and the Web Adapter or GIS Server in another group? And that might be a question for Subrat.
Hey, I think this is a very specific question with our traditional architecture, not Kubernetes related. So with traditional architecture, we used to have these 4 distinct component: Web Adapter, ArcGIS Portal, and ArcGIS Server and Data Store. Yes, you can have your ArcGIS Web Adapter in a different VNet as long as your firewalls are configured properly to allow traffic from the Web Adapter VNet to the Portal and Server VNet. It is possible, but you'll have to open the port 7443, 6443, 7080, and 6080. These are the ports, so those ports needs to communicate. But this is a question specific to our traditional architecture.
Yeah. That might be an opportunity to reach out to ask our experts. We would like to engage with you if there are kind of specific questions that have to do more with your specific environment. There are going to be more opportunities to engage with you. Subrat, while we have you, let's ask one more question here, which is, will there be any constraints limiting the migration of content or requiring change to content from a non-Kubernetes ArcGIS Enterprise to a Kubernetes-based ArcGIS Enterprise?
Yeah, so the migration story, we are still developing the migration story. It's not complete yet. However, as you know, the REST API that we are developing with ArcGIS Enterprise and Kubernetes is the same thing. We are not changing a lot in terms of REST API. So some of the old tools will still work, but there's a key thing, the ArcObjects version that we are using. So it works with the latest ArcObjects version, ArcObjects 11. So those map services that you want to migrate, those have to be published using ArcGIS Pro. That is one requirement. So other than that, as I said, we are still working on the migration story. So the more details will come pretty soon.
Thank you, Subrat. I know that we're going to be coming up to the end of the session soon. There are always going to be many more questions than we have time to get to. So again, there's another session following this one. And I wanted to just respond to several questions that are coming through about readiness. A lot of people are excited about Kubernetes, how they can get a little bit more comfortable with the technology or understand it a little better or train their teams up. First, we want to really highly recommend that you reach out to your current provider. If you're using AWS or Azure, there are some excellent learning paths and curricula already available out there. There is also quite a bit of information, documentation, and even some opportunities to try out some lab exercises. If you go to the Cloud Native Computing Foundation, go to kubernetes.io and then look for documentation. So there's quite a bit of information out there. Just want to make sure you're aware of that. We maybe have time for one more question, and unfortunately, we're going to probably run out at that point. And that is going to be back to Shreyas. So with this new architecture, will it be portal admin, server admin, and REST sharing interfaces, or will it just combine them all?
That's a good question again. So it has a single administrative interface now. That's the admin. It's a single endpoint where you go to do administrative work, change your log settings, manage security, manage licenses, and so forth. There is a single interface to go to your content and organizational access for items and content. That's your sharing, ArcGIS or your context/sharing. And then the other endpoint is your geospatial services endpoint, and those are available wherever your services are deployed under REST or under services. So we support and we preserve backwards compatibility with our REST APIs for geospatial services with REST and SOAP endpoints. So 3 endpoints for you to look at.
Thank you, Shreyas.
Back to you, Trevor. Yeah.
Thank you very much. And of course, as we approach the end of this session, there are far more questions than we were able to get to, but we tried to follow what was most voted by the audience. So where we haven't gotten to all the questions, remember that there's a channel for ArcGIS Enterprise on Ask Our Experts through the Dev Summit interface. There's also this second session starting up very shortly where we'll have more information about this really exciting effort. So we want to thank everybody for your attention, your questions, and we look forward to talking with you more. And thanks to the team here.